So we have a graph of current against potential difference, and the first part of this question is to determine the resistance of the filament bulb when the potential is 7 volts. So this is a case of just reading off the graph. Here's 7 volts. That crosses the curve around here. And the y-coordinate, the current value, would be about 1.44. So this coordinate is 7, 1.44. And then if we divide our voltage by our current, we then end up with our resistance. 7 over 1.44 would end up being 4.86 ohms, so about 4.9. So for the next part, sketch a graph of resistance against potential difference for the filament lamp over the range of 0 to 7 volts. So, first of all, when the potential difference is 0, our resistance will not be 0 as well. There will be some finite resistance. Whether you have current or potential difference going through or across your resistor or bulb, there will still be some kind of finite resistance. So, we're not starting at the origin, we're starting somewhere here. Only superconductors would have 0 resistance, and that's at very low temperatures. So, as our potential difference increases, this causes the current to increase, and as a result, the power dissipated in the bulb increases. That will increase the resistance of our filament lamp as the temperature goes up. So we know that resistance is increasing. That's generally the case for filament bulbs, as you increase potential difference. But how is it increasing? This is a 3-mark question. We're told that we want to get potential difference or resistance against potential difference over a particular range of voltages. So let's have a look at the graph and then have a think about how the resistance changes over different voltage values. So let's pick equal intervals of voltage. So let's consider the values 1 volt and 4 volts, and then we already have 7 volts. So I've picked those values because there's an equal jump of 3 volts in between them. And then let's consider what the current values would be for those voltages and then work out the resistances. So for 1 volt, when the voltage across the bulb is 1 volt, the current, I'm going to say that this curve kind of crosses halfway between these 2 points, in which case this coordinate would be 1 for the voltage, and for the current it would be 0.42. And for point with voltage value of 4, that crosses the curve around here. That's halfway between these 2 points approximately, and that will be 1.1. So this is 4 volts, 1.1 amps. And if we were to work out the resistance for each of these values, so do voltage divided by current, then we will end up with, well, we already know that the resistance here is 4.86. The resistance of the filament lamp at this point, 4 divided by 1.1, that will be about 3.64. And for this point, 1 divided by 0.42, that would be about 2.38. So what we see from these 3 points, the resistance is approximately increasing by about 1.2 to 1.3 amps each time. And the voltage increase is fixed as well. The voltage increase is about 3 volts each time. Voltage is increasing at a fixed rate. Resistance is increasing at approximately a fixed rate as well. That would imply that the gradient of this graph shouldn't be changing. Remember that the gradient of this graph will be change in resistance over change in voltage. And we've established that over fixed intervals of voltage, the resistance is approximately increasing by fixed amounts. So our graph will then end up looking something like this, with the endpoint, which we worked out. The voltage value for that was 7 volts. Remember, we're doing from 0 to 7 volts. And the resistance was 4.86. And that is part B done. On to part C. So it says, explain the variation of resistance with potential difference for a filament bulb in terms of particle behavior. So as you increase the voltage of a filament lamp, that increases the work done per unit charge, as that is what voltage is equal to. If we're increasing the work done per unit charge by your cell, that basically means that the electrons gain more energy. And if the electrons gain more energy, that means that whenever they collide with metal ions, they transfer more energy. The metal ion's energy then increases, and this causes them to vibrate with a greater amplitude. And if, on average, the metal ions are vibrating with a greater amplitude, well, that's the same thing as the temperature of the entire filament increasing. As your metal ions vibrate with a greater frequency and amplitude, that then causes there to be a greater chance of collision between the electrons and those ions, as the ions basically present themselves as a larger target for the electrons to hit, and this increases resistance. So if the resistance is increasing, well, that explains why the graph is doing what it's doing. If we have a look at the graph again, we can see that as the potential difference increases, the current increases, but at a decreasing rate. So I'll just break down what I mean by that. If we were to consider different points or different sections of our graph, let's look at low voltages, and let's pick an increment in voltage. Let's say 2 volts. So we're picking an increment of voltage of 2 volts from 0 to 2. We can see from our graph that our increase in current would be approximately 0.72 amps. But if we consider an increment of voltage for a higher voltage value, let's say between 8 to 10 volts, so it's the same jump, it's still a 2 volt jump, but now we're considering that at a higher voltage, then we can see from the graph that approximately the jump in current, or the increase in current, would be about 0.24 amps. So for the same increase in voltage, we're getting a lower yield in current, and that will only be the case if the resistance has increased. Okay, I think we're ready to write down a response that will get us some marks.